Hey everyone, today I'll be talking about the first line of defense for Search for Better Health in Biology for the HSC syllabus. The first line of defense is a part of the Search for Better Health syllabus, and it's basically just asking us to define the few things that act as the first line of defense in the body. So these things are the skin, the mucous membrane, cilia, chemical barriers, and other body secretions. So just here, right now. Anyways, so this first line of defense, it is a non-specific line of defense. And when I say something is non-specific, it means that it attacks anything that enters the body, really. It doesn't have to be a pathogen, it could be any foreign particle or substance. So we'll attack it. So we'll move on to the first thing, which is the skin. Now the skin, obviously, you already know what it does. It's just like a layer on top of our body. It covers our entire body, and it pretty much protects anything from getting in. Protects us from anything getting in. And it consists of this protein called keratin. Now, keratin is what pretty much composes of the skin, and it's also the same thing that makes your hair. Now, this keratin is impenetrable by pathogens unless it is broken. Now, when I say if it's broken, I mean if there's a break in the skin. So imagine if the skin had a cut, a laceration, or something similar. That means that it's broken and that something can get in. Now, anyways, we also know that we, us humans, we also sweat quite a lot, and we sweat for a number of reasons. One of them is thermoregulation, as you'd learn in PE, but for those that don't do PE, it's fine. I'll just tell you what the other reason is that we need to know for biology. So, believe it or not, in the case of keeping pathogens out, sweating is actually a good thing for us. Yes, of course, everyone doesn't like sweating. No one does. But, in this case, it's a good thing for us. And that's mainly because the sweat actually keeps the skin naturally slightly acidic. Now, when something is slightly acidic, most pathogens cannot live in this slightly acidic conditions. So, by keeping the skin naturally slightly acidic, we're already creating a surface which is somewhat inhabitable by pathogens. Now, we'll go on and we'll talk about more stuff that the skin has, which is potentially beneficial to us in the sense of keeping pathogens out. Now, every time I talk about this, I want you to realize that I'm not just talking about pathogens, I'm talking about any foreign substance. When I say pathogens, I mainly mean it because it's the overview of the topic, we're trying to keep pathogens out, but you have to remember that the first line of defense is always non-specific. And that's really one thing that characterizes the first line of defense. Now, anyways, the skin, it does do more good. We have microflora on the skin, and that does more good than harm. Now, just hearing microflora, you think of, it's some sort of organism, something like that. Well, microflora is basically just bacteria which isn't harmful to us. It's any type of bacteria which is pretty much harmless. You might have learned about parasites in year 11, and you might have heard of the parasites which don't actually do any harm to us, but in some ways they actually help us. That's exactly what microflora are. Now, indirectly, these microflora, when they're on our skin, they also create a more acidic surface. And when the surface is more acidic, it's harder for pathogens to live in. And it's good to mention also that microflora, since there's so many on our skin, where are the pathogens going to go? Where's the bacteria going to grow? Where, the virus is going to stay? There's not much space for the bacteria to be on the skin for if there's a lot of microflora. Now, everything is fine. The skin is a beautiful layer of defense, and it helps us a lot in keeping pathogens and foreign substances out. But if there is a break in the skin, there's a lot of things that can go wrong. Because as soon as there's a break, something can enter the bloodstream, and you're pretty much screwed. The second line of defense has to come into play. Now, even then, the microflora that you once thought was harmless, as I said before, can be of harm if there is a break in the skin. Now, what do I mean? Well, if you're a teenager, you obviously must have had pimples once in your life. Now, pimples, they're a result of microflora breaking into the skin. Well, most of them at least. They call them zits in America, and over here we refer to the bacteria's name, the scientific name, as this Propionibacterium acnes. So if that enters the skin, we get a pimple. It's as simple as that. The pimple is actually just an effect of the inflammation process, which is a part of the second line of defense that we'll learn a bit later. But anyways, we'll move on to the next part. So we're finished with the skin. Skin's pretty cool. It helps us protect ourselves. It helps prevent stuff getting in, and it's pretty swell. It's pretty good, as long as there's no breaks in the skin. Now, anyways, we'll move on to the mucous membranes. Now, mucous membranes, they're mucus-producing membranes, obviously, as the name says, and they line in the digestive, respiratory, and the urinary tracts with slimy mucus. Now, when you do take anything into your body, these mucous membranes can somewhat help you capturing this foreign substance if it is bad, if it's recognized as bad, or whatever it is that doesn't want to go there. And it can help us bring it back. It can help us just capture it, trap it. So, as I said here, the role of these mucous membranes is to trap the pathogen. So that's pretty much it, actually. I don't have much more to say, but that's what the mucous membranes do. They're just these sticky little. Mucus is this sticky substance which allows us to trap these pathogens. We'll move on to the cilia. Now, the cilia work in conjunction with the mucous membranes, so you can say that these two are linked quite heavily. Because when the mucous membranes actually trap the pathogens, there's no way for those pathogens to come back to the surface or exit in any way really easily. They're just trapped there in the mucus. Now, the cilia, what it is, it's like these tiny hair-like structures, which is like pretty much in a lot of places of our bodies, the nose, the trachea, and the throat. And what that does is that it gets these mucus from the mucous membranes. You get this mucus which has the trapped pathogens or trapped foreign substances and brings it back up to the throat. For example, in the trachea. So these cilia, they work, together with the mucous membranes in order to trap these pathogens and bring them back up to the surface. Now, another thing you might want to know about cilia is that we also have these cilia in our nose, and you might think, why do we have that? But really, it's the cilia acting as a filter for the air that's being inhaled in. And that really does help us when you do inhale air. That helps us filter out substances that we potentially think are going to harm us, or just any foreign substance in that matter. We don't want that to go inside our body. Okay, and the last one is chemical barriers. Well, if you ever really need to talk about chemical barriers, we can already talk about all the other stuff we've talked about in the beginning, which is also the sweat, which is also all that stuff. So the sweat that's coming out of our skin and oily layers on our skin, stuff like that. But if you really do need to talk about chemical barriers in more detail, you can talk about how our stomach is composed of, well, stomach has hydrochloric acid, and our small intestines have pancreatic juices. Now, as we know, hydrochloric acid is quite acidic, and in the small intestine, pancreatic juices, they're quite alkaline, meaning that they're basic. Now, if that's the case, think about it. If a foreign substance or a pathogen gets all the way down to your stomach, that isn't going to really survive, mainly because if it's so acidic in that stomach, it needs to be able to suit that acidic condition in order to survive. And after it goes into the small intestine, it needs to be able to suit the basic conditions as well. So unless you have some super pathogen, there's really no way it's going to go through the first and second line of defense. Now, before we finish up and before we just stop talking about all this first line of defense, I'd just like to note that it's really important to know that when you're talking about pathogens in general, sometimes, and most of the times, it's not actually the pathogens that make you sick. It's actually the toxins that the pathogens have produced before entering your body, which you then take in, which are going to potentially make you sick. Because those toxins can survive through quite a lot of stuff. And feel free to just read over these blobs of text, and I hope I do help with the audio. Anyways, thanks for watching, and good luck.